Okay, so this is the notes for Math 3 Unit 4, Objective 1. So we will be simplifying rational expressions. So a rational expression is just when we have a polynomial over a polynomial. So oftentimes people are just like, well, it's a fraction, and that's what we're working with. So we are working with fractions, but we will have polynomials in the numerator and the denominator. So there'll be variables involved that we'll have to be working with. So when we ask you to simplify, so when we are asking you to simplify in the directions, we are just asking that we have no common factor. So there is no common factor other than 1. So what we will be doing then is we will be reducing factors, and that's what it means to simplify. So with no common factor, we will be reducing factors. So reducing factors is not the same thing as reducing constants or terms. So we need to make sure we're understanding that we are working with factors. So if you need to make sure that you brush up on your factoring, go back and look at some of your old Unit 1, Unit 2 materials to review how to factor. Okay, so again, we will be dividing out common factors from the numerator and from the denominator. Okay. And we talk about fractions or rational expressions being undefined when the denominator is 0. So if it has a denominator value of 0, then it is undefined. Okay, and so when we are looking for excluded values, that is specifically when the denominator is 0. So when we ask for excluded values, we are looking for when the denominator is 0. Okay. So let's go ahead and take a look at the first example, but we're going to kind of run through the steps here as we go as well. So for our steps, the first thing we always want to make sure we do is we have to completely factor the numerator and the denominator. So if you did not factor the numerator or you did not factor the denominator, you probably have done something wrong. Okay, so remember, your first step is always to factor. So I cannot emphasize that enough. So again, make sure your first step is to factor. All right, so the different factorings that we have our GCF factoring, our trinomial factoring, and our difference of squares. Okay, so we're going to be reviewing all of those in fact these problems that we have here. Okay, so let's take a look at question number 1. So the first thing we want to do is we want to do what? We want to factor. Okay, so for question number 1, when I take a look at this numerator here, I have 4x minus 8, and so I only have 2 terms. So what I'm looking for is a common factor, right? So I'm looking for a common factor. So like what can I divide out of both of those problems? Okay, I'm going to zoom in just a little bit here. So I can divide a 4 out of both the 4x minus 8. So that means that's what I will be factoring, right? So I will take the 4, divide that out, and then when I divide by 4, I will get x minus 2. And so that is just the numerator. And again, I could check that, right? I could check that by distributing. So if I multiply 4 with the x, I would get 4x. And if I multiply 4 with the negative 2, I would get negative 8, right? And so that's what I started with. So that's how I could check it, right? And then now for the denominator, I have a trinomial. So I have 3 terms. So I'm going to do a guess and check, right? So I'm going to list my factors for x squared. So for factors of x squared are x and x. And then my factors for 16 or negative 16 are either 1 and 16, 2 and 8, and 4 and 4. And remember, I want one of those numbers to be negative because of that negative 16. And then I am trying to figure out what numbers are going to work that will help me find this middle, right? So I'm looking for that middle 6x that will combine from over here, x and x, with one of these over here, right? So I have to figure out which pair will work. And I know it will be the 2 and the 8 because that will give me a 6x, but it will only give me a 6x if I want a positive 6, so if that 2 is negative, okay? So if this 2 is negative, then that will give me my factors, okay? So I'm going to set up my binomials, my grouping. So I'm going to use x and x, and then negative 2 and 8. And it doesn't matter which one I put where, right, as long as I have that. Okay, so that was step one, right? So step one is to factor, right? And so now if we take a look at step two, my step two is I have to determine the excluded values, right? So determine the excluded values. And in order to do that, I set the original factored form of the denominator equal to 0, right? So I have to find my excluded values from the original. So from that x minus 2 and x plus 8. And so I'm going to do that just off to the side over here. So I'm going to zoom out here again. So I'm going to just do my excluded values over here, but I'm going to, there we go. So I'm just doing that off to the side. So again, I'm going to take my original denominator, x minus 2, my original factored denominator, sorry. So x minus 2 and x plus 8. And then I set that equal to 0. And then I solve this just like I did back in Unit 2. So from here, I'm going to set each factor equal to 0. So I'm going to use 0 product property. So I'm going to take x minus 2 equal to 0. And then I'm also going to take x plus 8 and equal that to 0 as well. So then when I solve this, I'm going to add 2 to both sides. And then the same over here, so subtract 8 from both sides. And so then my excluded values, so EV excluded values, are x equals negative 8 and 2. Okay, so just a reminder here, so let's take a look back at the very beginning right here. So again, remember excluded values are when our denominator is 0. So I took my denominator, set it equal to 0, and that's what I got for my excluded values. Okay, so step 1 is done, step 2 is done. So now let's go on to step 3. So for step 3, it's asking us to divide out the common factors, right? Or cancel the common factors that we have or reduce them, okay? So if I take a look at this very first one here, so I have x minus 2 in the numerator, and I have an x minus 2 in the denominator, so those are going to cancel each other out. And so then the only thing I have when I reduce that is going to be 4 in the numerator and x plus 8 in the denominator. Okay. All right, so 2 parts to our answers, right, is the simplified form and the excluded values. So both of those are answers to question number 1. All right, so let's take a look at question number 2. Okay, so again, our step 1 is to factor, right? So step 1 is to factor. And so if I look at the numerator, I can divide a 5x out of both of those, right? So both are divisible by 5x. So when I divide 5x squared by 5x, I get x. And when I divide negative 15x by 5x, I would get negative 3. Okay. And again, I can check that, right? I can check it through distributing, which is always something I should do, right? So if I multiply 5x by x, I would get 5x squared. When I multiply 5x by negative 3, I would get negative 15x. And so that gives me the same as that original numerator, right? Just going to go back in and do that. Okay, and then for the denominator, I have a trinomial, 3 terms, so I'm going to list my factors here. Factors of 9 are 1 and 9, and 3 and 3. And I'm trying to get that negative 6x. So I have to have a positive 9 when I multiply, so that means both of these numbers have to be negative. And 1 and 9 won't give me 6, so I know I'm going to use negative 3 and negative 3. So then that will give me x minus 3 and x minus 3. Okay. All right, so then once I do that, I want to find my excluded values. So I'm going to do that over here, and I'm just going to abbreviate that always EV excluded values. And so I take that original denominator that is factored. So that would be, so before I reduce, right? Before I reduce, I always want to take that original factored form. Okay, set it equal to 0. And then here it's the same factor twice, so I don't need to solve them different, right? So I would just set x minus 3 equal to 0, Could I write another one? Sure, but I'll get the same value. And then just solve. So I would add 3 to both sides. So then x is equal to 3 is that excluded value. So there's one part of my answer, right? Excluded value. And then now I go back to the same problem I was just working with, and I look to see what can reduce. So I see there's an x minus 3 in the numerator and an x minus 3 in the denominator. And so then my answer, my reduced form of that answer, will be there's a 5x left and an x minus 3. And so there's the second part of my answer, right? So I have two parts. I have the reduced form and the excluded values. Okay? All right, let's take a look at question number 3. So for this one, again, same thing. First thing I want to do is always factor. So in the numerator, I have a GCF, so I can take a 2x out of both of those. And when I do that, I'll be left with x squared and then plus 5, right? And so again, I could check it through distributing. And then in the denominator, x squared plus 5 have nothing common, right? So I could take a 1 out, but that certainly doesn't do anything. So I'm just going to go ahead and group it because I really can't factor any further. So I'm just going to leave it like that. All right, and then let's find our excluded values. So excluded values, so we'll do that over here. So I take that denominator that did not factor, and then I equal that to 0. And then just solve that equation. So I'm going to subtract 5. And then I'm going to square root. So here, when I go to square root, this is going to give me an imaginary number. Excuse me. And so that imaginary number is not going to be part of my excluded values. So I know it doesn't say it up here, but one of the things that it probably should have clarified, it's undefined when the denominator is 0, and an excluded value is a real number value. Okay, so a real number. So whenever we do domain and range, it's always the real numbers that we're referring to. So in this case, then there would be no real number excluded values. So for excluded values, then we would just say none. Because it's not a real number, right? Okay. All right, and then let's go ahead and finish out reducing. So if I go back to my problem here, they both have an x squared plus 5 in the numerator and the denominator. So they reduce, and so then the only thing remaining would be the 2x. And that would be the reduced simplified form, and then we have no excluded values. All right, so you should, or no, let's go ahead and do one more here. So let's take a look at question number 4. So for this particular problem, these are all single terms because I have no adding, no subtracting. So if I take a look at this, I have, just 21a squared b4, 7a cubed b squared. So there is no adding, no subtracting. So I would just reduce this like normal. And what I'm going to do is rewrite this as 3 separate fractions, not because I have to, but just so that we could talk about them easier. So all I'm doing is, oops. Let me get that. That should be a 3 here. And then my b terms. So again, this is not something I have to do. I'm just so I can talk about it. So all I'm taking a look at is I have that 21 over 7, right? And that's what I did right here. So 21 over 7. And then I have my a terms, right? There's my a terms. And I just wrote them as a separate fraction, not because I have to, again, just to make it easier for me to talk about. And then finally my b terms, I just put those together as well. And I can do this, right, because there's no addition, no subtraction anywhere. So what I want to do is I just want to reduce each of those separately from each other, okay? So I'm going to write it as a single fraction, though, in my final answer. So if I take 21 divided by 7, that would just be 3 over 1, but I don't need that 1, right? So that just reduces to 3. And then over here, a squared over a cubed. So a squared means I have 2 a's, right? And then a cubed means I have 3 of them. So 1, 2, 3, right? Isn't that what that means? So a squared and a cubed. So I have those 2 a's will cancel those 2, leaving that 1 on the bottom, right? So again, I have 2 on top, 3 on the bottom. So when I reduce that, it leaves only 1 on the bottom. So b to the 4th, so that means I have 4 of those on top, and then b squared means I have 2 of them. So b divided by b would be 1, another b divided by b would be another 1. So I'm left with that guy up there, so b squared in the numerator. Okay, so b times b. So then that would leave me with 3b squared over 1a, or a. Now, as far as excluded values, so this one's totally different because we couldn't factor, right? So this one is very different because we're not looking at our factors per se in terms of our traditional zero product property, but that concept still holds true. Okay, so let's take a look at the excluded values here. So I'm going to take my original denominator that did not need to be factored, right? And I equal that to 0. So then when I take a look at trying to solve this equation here, so I have 3 factors, right? So I have 7, which obviously cannot be 0, and then I have a cubed equal to 0, and then b squared equal to 0. So for here, I would just say, okay, then a is equal to 0, right? Because if I cube root that and cube root 0, I would still get 0. And then square root here, so that would just give me b is equal to 0. So again, all I'm doing here is I know that I'm cube rooting all of that. Well, the cube root of a cubed would be a, and then the cube root of 0 is still just 0. And then here, if I square root and square root of b squared is b, and then of course 0, 0. So then my excluded values are 0 for a and 0 for b. So a is equal to 0, b is equal to 0. And I'll just do an and symbol there. So my excluded values would be 0 for a and 0 for b. Okay. All right, and then let's go ahead and take a look at the last one on this page over here. So number 5. So again, I would factor first. So I have just already 1 term on top, so that won't factor any further. And then in the denominator, I can factor a 4 out of both of those, so GCF. And then when I look at that, so what I'm looking at is there's an implied dot right there for multiplying and right there. So that means 18 is a separate factor, right? From y squared, I can think of it as one term, of course, but factor-wise, 18 and y squared are, separated with that multiplication. So then because of that, what I'm doing is I'm reducing the 18 and the 4 is what I'm reducing. So I can divide, what can I divide out of both of those? I can divide by 2 for sure. Can I divide by 4? No. Okay, so I'm going to divide a 2 out of the top and the bottom. So when I do that, I would have 18 divided by 2 is 9. And then I still have my y squared. And then divide that 2 out of both, so 4 divided by 2. And then y plus 2. So again, all I did was reduce the 18 and the 4. And then nothing else in the numerator or the denominator would reduce, so that would be my reduced form. Okay, and then my excluded values, so let's take a look at those. So again, we're going to start from the original factored. So again, I know 4 is a factor, but 4 equaling to 0 doesn't make sense, right? So then I'm just solving for y plus 2 because that has a variable in it, and then solve that. So I would subtract 2 from both sides. And then there is that excluded value. Okay. All right, so that is page 1. So let's go ahead and take a look at page 2. Okay, so for this one right here, so this is just kind of more of that same. We're going to be just doing factoring and reducing. So if your factoring skills are pretty sharp, like you can keep going because this is not going to be anything different. We're just going to reintroduce that opposites idea. So if you think you're good, go ahead and press pause, try to do these examples, and then hit play and go back and double check to see, did you get the right solution or not. Okay, so let's go ahead and take a look at opposites, reminding ourselves about that. So something is considered opposite when you have your values, kind of flip-flopped. So like here you have x minus 4. If I were to flip that around, it would give me that 4 minus x, right? So those are called opposites. And that's because I can factor out a negative 1 from 4 minus x. And when I do that, I would get 4 would turn into negative 4. Negative x would turn into positive x with that negative 1, don't forget, factored there, which of course is just that. Okay. And so if I look at this particular problem, then I would see that I have x minus 4 in the numerator still. And then with that negative factored out, I would get that there. Okay. And then from there, I can see that the x minus 4 reduces, and I would just be left with negative 1. Okay. All right, so with that said, let's take a look at a few of these. So we want to recognize opposite factors, right? So that's what we're first starting with. Can I recognize if something is an opposite factor? So if I take a look at question number 1, I always want to make sure that I have my variable piece is positive. So if I look at the numerator, right, so if I look at the numerator, I have that negative on the x term. So I always want that positive. So that means I am going to first just rewrite it, put it first, just so it's in the right order. So that means that negative x should be first, and then that positive 2 second. So all I did was rewrite it, right? So I put the negative x first and the positive 2 second. And then I want to factor out that negative, right, because I don't want that x variable to be negative. So when I take out that negative 1, x will turn positive, but the plus 2 will turn negative. And then the denominator is fine because that is already positive. So the x minus 2's just cancel, and then I'm left with negative 1. Okay. All right, let's take a look at question number 2. So again, I always want that variable first, so I want that x to move to the front. So I'm just going to flip-flop it. So x is positive, 3 is positive. And of course the denominator is fine, so I don't need to do anything there. So then if I look here, these are exactly the same, so these are just going to divide out because they're exactly the same. And so then I would just be left with 1 over 1 or 1. Okay. All right, for number 3, I don't need to rearrange, right, because there's an x first on both the top and the bottom. I can't factor anything out of the top or the bottom. So these are not common factors, right? So if I group it, these are not the same, and if they're not the same, it doesn't reduce. So that would be my answer there. Okay. All right, and then let's take a look at the last one here, number 4. So for this one, it's this one that I want to flip around, right? So the numerator is fine because the x is first, but down here that negative x needs to go first, and then the positive 5. And then I always want my variable to be positive factored. So in the denominator, I'm going to take out the negative 1. So negative x turns to positive x, positive 5 turns to negative 5. And then just like the other one, then x minus 5's cancel. And then I'm left with 1 divided by negative 1, which is negative 1. So those are opposites. So in this case, 1 and 4 were the only ones that were opposite, right? So 1 was an opposite, 4 was an opposite. And I know that because I got a negative 1 when I reduced. Okay. All right, so let's go ahead and take a look at solving each of these. So we're going to start with number 5. So again, I always want to rearrange. So I'm going to rearrange my numerator because my x term I want first. So that would be negative x squared plus 4. So the 4 is positive, but the x squared is negative. So move that negative with you. And then here, this is in the right order in the denominator, but I could do GCF. So I'm going to factor a 7 out just to get that GCF going. And then now for number 5, I want to take out that negative, right? Because I always want that x term to be positive. So I'm going to take that negative out. So that would be x squared and then minus 4. And then we're still factoring, right? Still factoring. Okay, so I still have that negative there. But then when I take a look at this here, I have a difference of 2 squares, right? So x squared, 4, both of those are squares, and it's a subtraction, so difference of squares. So then that factors to x plus 2 and x minus 2. And then I look to see what can I reduce. So for my reducing, I have, let's see, they both have an x minus 2 common, so that will cancel. And I think that's it. So then my reduced form would be that negative, and then x plus 2 over 7. And there's my simplified rational expression. And now let's go ahead and do excluded values. So I'm going to take that original factor denominator, so right back there, and then equal that to 0. So then when I go ahead and do that, I don't need to solve this, right? Because 7 can't equal 0, so nothing to solve there. So then x minus 2 has that variable. So then just solve that. So I would have plus 2, so add to both sides. So then x is equal to 2. So then my excluded value is x is equal to 2. So that means I cannot let x equal 2, because if I did, I would have a 0 in the denominator. Okay. And then let's take a look at number 6. So for here, we're looking at just kind of reviewing our operations here. So for this particular problem, we did composition, but we didn't do like kind of the add subtract at the very first lesson. But we'll just go ahead and take a look at this one, but don't focus too heavily on this if it doesn't quite make sense to you, okay? All right, so what they want us to do on this particular problem is they want us to write f and g as a fraction. So that's what they're asking us to do with f in the numerator and g in the denominator. So here is f, I want that in the numerator, and here is g, I want that in the denominator. So they're not giving us the fraction, we have to create it ourselves. So we're going to take that 3 minus 3y in the numerator, and then 2y squared minus 2. So again, just a little reminder, like whenever we see, this kind of thing here, and we have these two separate functions, all they're asking us to do is merge them together and create one function, and they tell you how they want you to do it. So in this case, we're merging these two guys by writing them as a fraction. All right, so first things first, so I want to make sure my variables are in the right order, so that negative 3y should be first, and that plus 3 second. Oh, and let me factor. Let me do two things at once here. Okay, so I just rearranged the numerator, and then for the denominator, I just noticed I could take out a 2 from both of those. So let's go ahead and factor it, because we're doing lots of factoring. So I'm going to do a GCF, factor out that 2. All right, and then for the numerator, so I still can do some GCF, so I want that y to be positive, so I'm going to take out a negative 3 as my GCF, so that will turn into positive y, and then minus 1. And then for the denominator, I still have that 2 there. And then that second portion is a difference of squares. So this is right here a difference of squares. So I want to make sure I group that out. So that would be y plus 1 and y minus 1. So difference of squares. So it looks like we're good on that factoring. So now I just look to see what can I reduce. And I can see they both have a y minus 1 common. So that cancels. And so then my reduced form, so the only thing I have left in the numerator is negative 3. And in the denominator, I have a 2 and a y plus 1. And there is my simplified form. Okay, so now for my excluded values, I take that original denominator that is factored. Oops, how about this guy over here? This is one fully factored, so before I canceled. So that first one I circled wasn't factored all the way, so that's why I went to the next one. So excluded values. And then now set each factor equal to 0. So again, 2 can't equal 0, so that's not helpful. So I have y plus 1 equal to 0, and y minus 1 equal to 0. And then just solve each of those. So this one again doesn't solve, and so I'm going to subtract 1. And then add 1. So then my excluded values are y equals negative 1 and 1. Okay. All right, and last two problems here. So if you haven't already, hopefully you have pressed pause at some point, tried your skills at factoring, see how that fares, and then solve these yourself and then play and check your problems. Okay, so number 7. So again, the first thing I always want to do is get my variables in the right order. So I'm going to get that negative w cubed first and then positive 64 second. And then while I'm at it, I'm going to go ahead and factor the denominator. So I have a trinomial there. So do a little guess and check. List your factors for each of those. So for number 7, because that's a positive 16, but I have a negative 8w here, I know these have to both be negative, right? So all of these should be negative. So then when I look to see, okay, what's going to work, I know I have to get a negative 8w. That's what I'm trying to get. Well, that won't help because that gives me 17. 2 and 8 gives me 10. So it's got to be the negative 4 and negative 4. So then my denominator will be a w for both of those and a negative 4 here. Okay. All right, let's go ahead and keep factoring there. So in the numerator, I'm going to go ahead and take out that negative. Okay, so cubic factoring. Okay, so let's do a little review on cubic factoring to kind of help us out with this, like right here. So cubic factoring. Or SOAP, right? So you might have heard that as well, right? So cubic factoring or SOAP. So just a reminder of that pattern. So it was a cubed minus b cubed. So if it's cubic, you have a binomial of the cube roots, and then you have a trinomial where you square, so a squared, and then you multiply these guys together, so a times b, and then this should be opposite, right? Because remember, this sign is the same, this one is opposite, and then squared, always positive. Okay, so that's just a reminder of that cubic factoring in case you forgot. So that was back in chapter 2. I forget what lesson that was, but if you want to go back and look at your chapter 2 notes to kind of review that as well. Okay, so let's go ahead and finish up this problem then. So for here, so I have that negative out front, right? And then, so now my cube root, so w cubed minus 64. So this is like your w cubed minus 64. So then a would just be w, because the cube root of that. And then b would be 4. Okay, so a minus b, so that would be w minus 4. And now for my trinomial, so now I'm going to do a squared, so w squared. And then multiply a and b together, so multiply those, so that would be 4w. And then don't forget opposite, so this is going to turn into a positive. And then b squared, so 4 times 4, so 16, always positive. That's my numerator, and then my denominator is still the same, right? So w minus 4, and then times itself. Okay, and then I can reduce it. So the w minus 4s cancel, doesn't matter which one I cancel it with, so I'm just going to cancel it with that front one. And then let me give myself just a little bit of space here. Otherwise I'm going to not have room. Okay, so I'm left with that negative on top, and then the trinomial, and then a w minus 4 on the bottom. Okay, and then excluded values, so let's go ahead and do that. I'll just steal some room down here. So for my excluded values, I'm going to take that original factored, so this one right here. And then set each factor equal to 0, but these are the same, right? So if I set them both equal to 0, I'm just going to get the same answer each time. So I'm just going to solve for 1. And so then my excluded value is w is equal to 4, right? Meaning w can't be 4. We're excluding that value. Okay. because if it were, then I would get a 0 in the denominator, right? Undefined. Okay, last one, number 8. So if you have not yet pressed pause and try these on your own, you should definitely do it for this last one. Okay. So for this particular problem, I have my numerators in the right order, but if you take note, these are exactly the same, aren't they? Or not the same, but they're like terms. So I'm going to go ahead and combine these two guys. So for number 8, I'm going to start with combining my numerator. And it's like terms. So negative 2m and negative 1m add up to negative 3m. And then for the denominator, I want to get that in the right order, right? So I want to put that in the right order. So the negative 2m should go first, and then that positive 4 second. And then we want to go ahead and factor. So number 8 is guess and check. So m squared is m and m. And then the only way to get a 2 when you multiply is a 1 and a 2. But we want it to be negative in the middle, so that means these have to both be negative, right? And again, I could check it if I wanted to, right? Certainly something I could do. So m times itself is m squared, check. M and negative 2 is negative 2m, check. And negative 1m, which combine to give me the negative 3m. And then negative 1 times negative 2, positive 2, right? So that's how I would check that, right? Just distribute that out, and then that would give me those values. Okay, and then for the denominator, I could do a GCF, and I want this to be positive, so I'm going to make sure I take out that negative as well. So I'm going to take out a negative 2 for my GCF. That would give me a positive m, but then a negative 2. And again, I can distribute to check that, right? Okay, so then m minus 2 cancels. And I am left with m minus 1 in the numerator and then negative 2 in the denominator. All right, and then finally, very last, excluded values. So I take my factored denominator, which is this one right here, right? Because this is not factored, so I want to make sure I take that one. Set it equal to 0, and then solve each factor. So again, I would not solve this, right? Because negative 2 doesn't have a variable, and it certainly can't equal 0. And so I'm just solving the factor with a variable in it. So just that m minus 2, equal that to 0. And then just do your normal solving. So I'm going to add 2 to both sides. So m equals 2, and so that is my only excluded value. And again, last time to say this. So when I say excluded value, m is equal to 2, it just means that if I were to let m equal 2 up here, I would get a 0 in the denominator, and we don't want that, right? Okay, and that's it.